The lesson topic for this video is solving polynomials using the factor theorem. So what you see in front of you here is actually two examples I did in the notes yesterday or previous day on synthetic division. What I want to point out here is that there's a difference between this solution here and this solution here. And that difference is that this example produced a remainder and this example did not. Now, if you think back to division when you were younger, if we had 9 and we were going to divide by 3, we would get 3, and we do 3 times 3 is 9, and we would subtract and get 0, and therefore we knew, what we found out is that this 3 that we divided by is actually a factor of 9 because it divided into it exactly with no remainder. Okay? Whereas we've had also experiences where we've taken a number, let's say 10, and divided that by 3 and said, okay, 3 times 3 is 9, and we subtract and we get 1, and we have a remainder of 1. Since we have a remainder of 1 here, we know that 3 is not a factor of 10 because it did not evenly divide into it. So, sorry, trying to erase here. So, what that tells us is, if we have a remainder right here, that tells us that -1 is not a, well, I should say x plus 1 right here, is not a factor of this polynomial. So if we were to factor this polynomial, we would not get x plus 1 as one of our factors. But over here, okay, our remainder is 0. And if our remainder is 0, that means that this 2 here divided into that evenly, which means that x minus 2 right here is a factor of this polynomial. So if we were to factor this polynomial using our factoring methods, we would find x minus 2 to be one of our factors. So to sum that up here, that's what this says down here. If a polynomial is divided by a factor, and that's right here. If a polynomial is divided by a factor, then the remainder will be 0. All right, reading that kind of the reverse, the converse, as we learned in geometry. If the remainder, when dividing a polynomial, so when the remainder is 0, then we know that the divisor is a factor. All right, let's look at how this will help us. So those statements on the bottom of the previous slide sum up the factor theorem, which is listed right here. So the factor theorem says, again, same thing as the previous screen, a polynomial in function form f of x has a factor, x minus k, whatever that number is there, if and only if f of k equals 0. All right, so given this example here, given that x plus 4 is a factor, so if I'm telling you that x plus 4 is in fact a factor of this, we need to factor the function completely. All right, so since we know this is a factor, we know that when we divide that divisor into our dividend, we will get a remainder of 0. So let's do that using our synthetic division that we learned on a previous exam or previous lesson. So we're going to start by writing our coefficients. So 1, again from right here, this 1, positive 6, 5, and negative 12. Notice I did not have to fill in with any zeros because we have x to the third, x to the second, x to the first, and then x to the 0 or our constant. All right, so we're going to put our bracket down, and we are going to take that x plus 4 equals 0, subtract 4, just like we did on synthetic division yesterday, or previous day, and we get x equals -4. So we want to divide by -4 right here. All right, so same steps, bring down the 1, -4 times 1 is -4. We're going to add 6 plus -4 is 2. We are going to multiply here, -4 times 2 is -8. And then we're going to add 5 plus -8, which is -3. And then we're going to multiply -4 times -3, which is positive 12, negative times a negative. And when we add, we get 0. And it's a good thing because, again, I said it is a factor, so we knew the remainder would be 0. So now we're going to rewrite this. We've got 1x to the second power. Again, that number is always 1 less than this, so x to the second, plus 2x minus 3. All right. Now what we are left with is a quadratic right here. You'll notice a quadratic expression. And we need to factor completely. So we're not done. We know one of the factors is x plus 4. We need to find the rest of the factors of this polynomial. So what we're going to do here is we're going to factor it. Okay? So we're going to put an x here and an x here because x times x gives us the x squared. And now we need the number here and here that when we multiply them gives us negative 3, and when we add them gives us positive 2. That will be plus 3 and minus 1. You can check that math if you need to. So those are our other two factors. So if we're going to write our completely factored form for this function, we would write f of x equals x plus 4, and we have that factor from, again, the original problem. X plus 4 is a factor. X plus 3 and x minus 1. Okay, why don't you go ahead and pause the video and try this example, come back and check to see how you did. And then on the next slide, I'm going to talk about something just slightly different but related to what we're doing right now. Okay, so I've done most of the work here to get to 3x squared plus 13x plus 4. Just so you know, again, that is synthetic division, but we are not done because we are going to factor completely. So if you didn't continue, go ahead and continue now. Factor that using magic number or AC method, and then check back. Okay, so I factored that using magic number or magic term, and if we factor completely, we get g of x equals factored form. We've got x minus 5 from the original problem. They told us that x minus 5 was a factor. 3x plus 1, x plus 4. Okay, so we need to talk about a little bit of vocab before we continue, and that is this word right here. Okay, it says, given the polynomial function f and a 0 of f, find the other zeros. Okay, so this word 0 is not what you think of when you think of the number 0, okay? A 0 of a function is another way to say a solution to the function, which will also be your x-intercepts. And we'll talk more about all of that on previous or later lessons and in class. So if we're asked to, if we're told that we're given a polynomial function f and a 0, which is a solution of the function, find the other zeros, find the other solutions. Okay? So to do this, we are going to start by using synthetic division with the one solution that we're given, or the 1, 0. Then we're going to factor the remaining quadratic, just like we did on the previous slide. And then we're going to write it in factored form, and then we're going to solve from factored form using the zero product property. All right, so this first example, f of x equals x to the third plus 2x squared minus 9x minus 18. And then we've got our semicolon and a negative 2. So our negative 2 is our 0, is our solution. Our solution is negative 2. Now what does that mean? I just have to talk to you about this quick. Negative 2, therefore, is a solution, which means that we had a factor, x something here, that when we solved it, we get x equals negative 2. So what that means is we technically have a factor that is x plus 2 if our solution is x minus 2, because we would subtract that 2 from both sides using the zero product property. I point that out because what this means is when we're doing our division here with synthetic division, we are going to write this negative 2 right here as it is negative 2. Okay, we don't have to set this equal to 0 and solve because it is already done for us, because it's the solution. So negative 2 goes off to the side, and we're going to use our process for synthetic division. Okay, notice we get 0 as a remainder, as we should have, because negative 2 is a solution, which means that x plus 2 is a factor. And now we have 1, 0, negative 9. So what we have here is we have 1x squared plus 0x, so I'm not going to put that in there, and then minus 9. What do we have here? Well, we have a difference of squares. So we're going to put our parentheses down, We're going to factor. Notice we did our synthetic division. We're going to factor the remaining quadratic expression. So we have x here and x here. 3 times 3 is 9. 1 needs to be positive and 1 needs to be negative. So we now know that x equals -2 is one of our solutions, and we need to find the other 2. And I know there's 2 because there's 2 other factors. So we use the zero product property. X plus 3 equals 0, and x minus 3 equals 0. And we find out that our other 2 solutions are x equals -3 and x equals +3. Again, I would suggest that you pause the video here and do this problem on your own. Check back to see how you did. But what we're trying to do here is find all the other zeros. Again, the same directions as the previous slide. So we know that one of our solutions is 3. So if we wanted to put our solutions over here, we know that x equals 3 is one of our solutions. Our job is to find the other solutions, or zeros. Okay, as you set it up, there were no missing terms. Remember, we're dividing on the outside by 3. Okay, and you get the polynomial 1x squared plus x minus 20 with that remainder of 0. And now we factor. X times x gives us the x squared. We're going to need a +5 and a -4 to multiply to give us -20. And that add up to the 1x in the middle here. So x plus 5 equals 0, x minus 4 equals 0. We're going to solve those. And there is our solution, or all of our zeros.